We are going to talk about synthetic division as well as the remainder and factor theorems. This is a fairly straightforward process if you remember synthetic division within the Algebra 2. This is specifically for a college algebra class. When we do our synthetic division, we want to write our answer as the quotient plus the remainder over the divisor. Sometimes we see it written in other ways, and we'll talk about that here in a second. But let's go through the examples so you can see how this works. The first thing we're going to do is we're going to solve the coefficients in order with our exponents. So if we're missing a term, we have to put a 0 in that place. There's an implied 1 right here. So our coefficients are 1, -3, -14, and -8. So x to the third, x squared, x, and then no x's. Over here, we'll have our kind of our backwards L, or our side box, and we'll put in our 0 of this. So we'll take this term right here, we'll say, okay, that equals 0. Therefore, x would be -2. That's what goes in this box, is -2. We kind of draw a line underneath our last term here. We can draw a straight line. What's going to go down here is our remainder. All right, our first thing we do is we take the very first term here, first coefficient, and we just drop it. Then we multiply these, so -2 times 1, and we will put that answer right here, is -2. And then we add going down. And then we'll do it again. So we'll take this -2 times -5, and we'll put that answer here. Should make that bigger so we can see it. -2 times -5 is 10. Then we'll add. We'll get a -4. And we'll follow the same process. So -2 times -4 is a +8. So when we add that, we get a remainder of 0. Now, if you recall, this was an x to the third, x squared, x, and no x. So we're dividing out an x. Well, x to the third divided by an x is an x squared. So let's rewrite our answer down here. We're going to have a 1 x squared minus 5x minus 4. Then it says plus the remainder divided by the divisor. Well, our remainder is 0, so we don't actually have to do that part. So right here is the answer to our division problem. Every now and then you will see, instead of it written like this, it'll ask you to write it like this. We're going to have our dividend equals our divisor times our quotient plus the remainder. It's just another way of writing it, but really either one's going to be okay. So just pay attention to the directions to see how this works. And if that's the case, what this would look like in our answer, let's change colors so we don't get it mixed up. So this answer would be our dividend, which is the thing that we're dividing by. So x cubed, our thing that we're dividing. So x cubed minus 3x squared minus 14x minus 8 equals our divisor, so that's the thing we're dividing by, times our quotient, this would be the answer we got, so x squared minus 5x minus 4, plus our remainder, which would be plus 0. That would be how we write it in this form. And this one right here is written in this form up here. So let's look at another one. Why don't you guys try pausing the video and see if you can figure this one out. But if you haven't paused, we are going to move on. So once again, we're doing this top divided by the bottom. If we set the bottom equal to 0 and solve it, x equals 2. Once again, that's what goes in this backwards box. We throw all the coefficients here. So 3, so I should say x cubed, x squared, x and no x. So I'm going to do it this time without all the arrows. I do usually put this arrow just to kind of make sure we stay lined up. And then under this one is our remainder. All right, 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. Negative 4 plus negative 6 is negative 10. 2 times negative 10 is negative 20. 23 plus a negative 20 is 3. So let's think about this again. We've got an x cubed here, which means this will be an x squared. So our answer, written in that original form, will be an x squared minus 3x minus 10 plus 3 over our divisor, which is what we're dividing by. So here's our answer to that. See if I can get a circle or a box or something around it. There's our solution. Hopefully that's what you got. All right, now the remainder theorem, what this does is it allows us to solve this, which really means plug 2 into each of these x's without actually having to plug 2 into those x's, because sometimes the negatives especially can cause people problems. But what we're going to do is we're going to take this number exactly as it is, and that's what goes in this box. Then we do our coefficients. So we've got x cubed, x squared, x, and 12. So we're not missing any coefficients. So we've got 1, negative 6, 5, and 12. And we're just going to do our synthetic division just like we have been. So we're going to drop this down. So 1, negative 2 times 1 is negative 2. Negative 6 plus negative 2 is negative 8. 16, 21, negative 42, negative 30. I forgot to draw my line. So this is my remainder. What the remainder theorem tells us then is that p of negative 2 equals negative 30. I don't need the whole divisor. I just want to know, what is p of negative 2? Well, p of negative 2 is negative 30. So that right there is our remainder theorem. So I want you guys pause the video and try this one. And then we'll work through it right here as an example. So if you haven't paused yet, you might pause. Otherwise, we're going to just roll right in. So like I said, we don't change this. So we're going to have 5 in our box. And then our coefficients. So they'll look exactly the same as they did. Negative 6, 5, and 12. Sometimes our numbers get a little bit bigger, but we will find out here. So this is going to be the remainder, or the answer. So we drop 1 is 5 is negative 1. Negative 5 is 0. 5 times 0 is 0. And then 12. That means that p of 5 equals 12. Hopefully that's what you got. All right, now let's look at this in a different way. So this is called the factor theorem. The factor theorem allows us to use synthetic division to factor a polynomial. To start with, in this lesson, we're going to give you one of the zeros. So let's do synthetic division to start with that. So we'll have a negative 3, and then I like to check my x's again. So cubed, squared, to the first, and none. So we are not missing any terms. Remember, if you're missing a term, you have to put a 0 in that spot. All right, so we've got 1, negative 3, negative 13, and 15. All right, dropping our first term, so 1. Then we multiply, add, multiply, add, multiply, and add. You should get a 0 here because it tells you that this is one of the zeros, which means there shouldn't be a remainder. All right, so right now we've got an x squared minus 6x plus 5. That's what we need to factor. So what multiplies to be 5 and adds to be negative 6? Well, it'll be a negative 2. Nope, that's not right. Back up. So it multiplies to be 5 and adds to be negative 6. So it'll be a negative 1 and a negative 5. So negative 5 plus negative 1 is negative 6. -1 times -5 is 5. Well, the problem is that we had another 0 up here. Remember this one? So we have to figure out in factored form what that would have been. Well, remember this is what we would have had if we'd solved it. So let's unsolve it, which doesn't really make sense to say it that way, but that's what we're doing. So we'd have x plus 3 equals 0. So in here, we'll have an x plus 3. This is our completely factored form. So f of x equals this right here. And we're going to talk about another way you can think about this instead of doing it this way in the next problem here. But that's using the factor theorem. Let's use the factor theorem again to write a polynomial with the indicated degree, which in this case is a degree 3. So these are the zeros. I'm going to tell you, when you write it as a factor, it's always going to be x minus the 0. In this case, I have 3 zeros. So I'm going to have x minus a -2, x minus square root 10, and then x minus a negative square root 10. Well, minus a negative, if you recall, that turns into a plus. So I'm going to have x plus 2, x minus square root 10, and then x plus square root 10. All the degree 3 says is that I'm going to have an x cubed. That's what that tells us. The a equals 1 means my leading term will just have a 1 here. That's all this part means. Really what it's asking us to do is to FOIL all this out. I would recommend foiling these right here first because they're conjugates. And you could do your traditional foiling. So, your x squared right here would be plus x square root 10. Right here will be minus x square root 10. And then these right here would end up being minus square root 100. Well, notice these two things cancel, and the square root of 100 is 10. So I'm going to have an x squared minus 10. And then we'll have to FOIL this in. So I'm going to write that here, and then I'm going to talk about that top part there just really fast. Then we'll FOIL this out. What I wanted to point out to you is, since these are conjugate pairs, we have this rule that tells us we have a squared minus b squared. We actually call it a factor rule. Then this would be a minus b and a plus b. Well, it works in reverse. So here I have the a minus b and the a plus b. Really what that means when I multiply it out is I'm going to have my a squared minus my b squared. So I have x squared, and the square root of 10 squared is just 10. Notice that's the same thing as what is over here, right? You can use either way. Like I said, you can FOIL it out if that's what you're most comfortable with, or you can use this rule. That's entirely up to you. But now we need to finish FOILing because we had 3 terms and you only do 2 at a time. Let's multiply. So x times x squared is an x cubed minus 10x plus 2x squared, that's a plus, and then minus 20. Not a big fan of having things out of order, and it says it's a polynomial p, which means we're going to have p of x equals, let's put it in standard form, so x cubed plus 2x squared minus 10x minus 20. This right here, ooh, that's a terrible circle, sorry, is our expanded form. And these are the things that we talk about when we talk about the synthetic division, the remainder theorems, and the factor theorems. So hopefully this made sense, and we hit these things. So you will divide polynomials. We use synthetic division to do that. And then you're also using the factor and remainder theorems to help solve problems.